So learning target 9, day 3, we're still focusing on solving multi-step equations. We're going to look at a couple of special cases, fractions and decimals, and how to work with those successfully. I know a lot of you don't like fractions and decimals, but there are ways to work with them and make them work for you instead of against you. So when you see an equation with fractions, the first thing that you want to do is find the least common multiple or the least common denominator. So looking at 2, 3, and 4, all of the fractions on both sides of the equal sign. What do 2, 3, and 4 all go into? Least common multiple. We're not looking for a common factor. What goes into them? So some of you learned least common multiples by making lists. If you're going to make a list, start with the highest number. Actually, in this case, I think I'm just going to do the list. So 4 times 2 is 8. 3 does not go into 8. 4 times 3 is 12. 2 goes into 12, and 3 goes into 12. So 12 is our least common multiple or common denominator. Now, once you have that information, there's two things that you can do with it. You can either change all of the fractions so that they have a common denominator and then work with them from there, or you can multiply everything using the golden rule of algebra and get rid of the fractions altogether. So I'm going to show you both processes. And over here I'm going to do method 1, multiply. I'm going to show you kind of the new method, multiply by least common multiple. So here's what happens when I do that. So here's my method 1 right here. I am going to take my equation and multiply everything by 12. So my first term, x divided by 2, now I'm going to take my 12 and divide by 2 and get 6. So I've got 6x. My second term, 1/3, or 1 divided by 3. Now I'm going to take the 12 divided by 3 instead and get 4. By the way, I will, on this one, show you what happens if that numerator isn't 1. So 12 divided by 4 is 3, but now I need to multiply it by the 3 in the numerator to get 9. So if you didn't understand that one, let me kind of show it to you a little bit more clearly. This is like, and I know a lot of you like making the integer into a fraction. This is when you multiply fractions, you simplify before you multiply. 4 goes into 12 3 times, and then I've got my 3 times 3 to give me the 9. Now I have an equation with no fractions that I can solve much more simply than I can solve the one with fractions. So I'm going to add 4 to both sides to cancel my minus 4. And then divide both sides by 6. Remember, on the side with the variable, I am canceling, leaving me with x, and 13/6 is simplified. All right, so let's take a look at method 2, if you're not really a fan of that one. Sorry, that was method 1. Change fractions to least common denominator. All right, so here's my method 2. And in this one, I'm going to multiply my first one by 6/6 so that it has a denominator of 12. My second one, to get a denominator of 12, I'll multiply by 4/4. And my last one, I'll multiply by 3/3. Now look what happens in the numerator when I change this. So we've got my first fraction, I've got 6x/12. My second fraction, I've got 4/12. And my last one, I've got 9/12. So look at those numerators. 6x minus 4 equals 9. Once you have a common denominator, you can go ahead and drop it. But that's just following method 1. So I'm going to show you method 2 using the fractions. So I will cancel my 4/12 by adding it to both sides. Now remember, when you've got a common denominator, you add the numerators, leaving the denominators alone. So now I've got 6/12x equals 13/12. And essentially, if we look at this a little bit differently, we can think of it as 6/12 times x. How do we cancel multiplication? By division. But when I've got fractions, the rule is to multiply by the reciprocal. So I'm going to multiply both sides by the reciprocal. Now remember, why am I multiplying by the reciprocal on the left-hand side? To cancel. So notice my 12's cancel and my 6's cancel, isolating the x. On the right-hand side, my 12's cancel, which is why I found that common denominator for all of my fractions, leaving me with 13 in the numerator and 6 in the denominator. Now I'm hoping that you will see method 1 is a bit easier than method 2 because you get rid of the fractions in the first step instead of keeping them all the way through. But again, they're both legitimate methods for solving an equation, and if you like method 2, great, go for it. I just need to finish filling in the steps over here. And these are the same steps we've seen for solving equations. So we used order of operations backwards to decide what to cancel. Step 3, we used our golden rule. And step 4, we need to repeat as needed.